has had to deal with people putting other people's names in other objects so that they were referenced. Are you landing?
Landing the questions.
Come on in. Join us. It's going to be fun. I'm going to divulge all kinds of tricks so that you can steal people's identity. Oh, no, I mean, so that people can't steal your identity. It's 9 o'clock. Emanuele, how are you?
Nice to meet you.
Take any seat, yes. Take a seat where nobody else is sitting. This reminds me of a Middle Eastern Network Operators Group meeting several years ago, where we had planned to have lots and lots of people, and then there were like some terrorist attacks in Istanbul, and then they didn't show up. And we had this enormous, enormous room for like maybe 10, 15 people. Yeah. We're going to wait don't mind so that we can see if other people come up and join us. Grab them by the collar and drag them in. I know, I know what? I'm going to start playing the Kahoot music, see what happens if people show up. Good morning. Oh dear. Should have brought my sunglasses. Who's that? Who's coming in? Look, I even got the red meet and greet t-shirt. Come on, people. Come meet and greet. Wait 2 more minutes, and then out of respect for the people who actually showed up, we'll start. Let me try another trick. I know a trick how to get free IPv4, free /24s in this room. See, they're coming in masses now. Did I say free IPv4 /24s? And they're clean. They're rootable. I'm going to give out Andre's password. Free IPv6 subnet calculators. Come on in. You won't regret it. Or maybe you will. Yes. It could be. How do I change that? Settings. Oh, look, there's an update. Night shift. It says off.
Oh, okay. All right.
See?
And it's just terrible color. No, it's just bad color on the projector.
Should I put it less warm, more warm, or
Well, cooler, right?
let's see. Ooh. Tell me where to stop.
Well, we're not. You're showing
Oh.
trees now, so I
Yeah.
don't know.
Let's see.
I think it's the same way before. Yeah. Just never mind.
Okay. I will ignore you. Very well. It's 9:06, people. Let's get this party started. Good morning. I hope you've had your coffee. I had too, so I hope I have enough boom, boom, oomph to get through this. Welcome to this tutorial on protecting your ripe data. And it's just a simple guide. I'm not going to tell you exactly what you have to do, but I'm going to give you some tools, some skills, and some best common practices, and of course, some common knowledge. What we're going to be exploring today is basically this. So first of all, why secure your ripe database objects, right? It's just a registry. What effect can it have on our networks or on the internet in itself? We're going to look at maintainers. There's quite a lot of changes coming up with maintainers, so I'm going to put you up to speed on what's happening, what's going to happen. We're going to look at some ways to get notifications on updates. So when an object is updated or an attempt to update an object happens, then we really want to know that that is happening. We're going to look at how to control references to your objects. Sometimes we have objects which we don't want to have reference in other objects, and there are ways to stop people from doing that. Like, for example, did you know that if you try to create a route object, you can just put in the AS number there, and there is no way anybody can stop you from doing that, except if you control the references. We're going to also look at AS sets and enum objects, and then we're going to wrap it up with looking at the two new init-num object statuses, and then have a section on, or have some time to carry out any demos that you might want to have me carry out. It's always it's always fun to do live demos because they can go wrong, and that's when we have fun. Anyways, the ripe database is not just a static repository of information. It's also a dynamic tool that plays a critical role in the day-to-day operations of the internet. By keeping your entries accurate and up to date, you're not only benefiting your own organization, but also contributing to the broader internet community. And that's what the internet is about, collaborating with each other and getting this whole large network of networks running. So why is it important to have an accurate registry? Well, it's like it says there, it's fundamental to maintaining a stable, secure, and efficient internet. Accurate registry helps with troubleshooting. For example, when network issues arise, having an accurate registry which has correct information on how to contact other networks is actually very invaluable. Other engineers can quickly identify a network's point of contact and technical details and facilitate faster problem resolution. Another important aspect of keeping an accurate registry is the resource management and, of course, future planning. The ripe database provides valuable insights into IP address allocation and utilization trends, and this helps the internet to manage the resources which aren't eternal. They're not endless, of course. So it helps for IP address allocation and long-term sustainability. It also facilitates peering and network interconnection. The internet thrives on collaboration between different networks. That is the definition of the internet, right? Networks connecting to each other and being able to share traffic and data. When you need to establish connections or set up peering with other networks, having your IP resources correctly registered builds trust. and streamlines the process. And in these days, having trust in another network is really important. We want to know with whom we're connecting, with whom we are sharing our data lines. Come in, take a seat. So networks are more likely to peer with you if they can verify your address space and contact information. So if it's correctly registered, they're sure to trust you more easily than if it's not. The accurate registry also helps with abuse prevention and mitigation. Having accurate registration information is crucial for combating malicious activities online. And when you can maintain your contact details up to date, it also allows security researchers and incident response teams to quickly identify and get in touch with the appropriate network administrators in case of abuse originating from one of these networks. Another thing that the registry helps with is routing efficiency. The information that you register, particularly your routing policies and peering preferences, directly impacts how traffic is routed to and from your network. So in case you didn't know it, the registry has a big operational impact. Accurate data helps other network operators make informed decisions about routing, potentially improving your network's performance and reducing problems. Many network management tools and scripts rely on data from the RIPE database. So setting up filters, automation, stuff like that. And having an accurate registry helps with automation. Nowadays, that networks are getting more and more complicated. Having a good and stable automation is actually very important. So some RIPE database objects actually have an operational impact. And this means that if those objects are modified or deleted in some way, they can actually impact how this network is connected or seen on the internet. They can affect routing, security, and inter-network operations. The 4 objects that have this type of direct impact are the route for IPv4 routes, route 6, the AS sets, and the domain objects, which are for reverse delegation. Now, keeping them secure at all times is actually very critical, and I cannot stress it enough. Make sure that your route and route 6 objects especially are protected, because they can really affect the visibility of your network out there. So let's look at these objects in close detail so that you can recognize them in case you don't know them. The route and route 6 objects define the authorized origin AS for a prefix. So in the route object, we're going to specify which IPv4 prefix is going to be announced or originated in BGP by which AS number. And when this object is present in the database, it's used by other networks to set up their filters. And so if the object is in the database, the other networks will probably accept a BGP update coming from your, or BGP origin coming from your network. Same thing with route 6 objects. In this case, we see IPv6 prefix and AS number. They are quite sensitive in the sense that if they're deleted or removed or modified, they can cause a network to be disrupted. So the routing might be disrupted. Deletion could lead to your prefixes being filtered out by other networks, causing partial or complete loss of reachability for your IP space. Also, for example, if they're deleted, it can result in your services becoming unreachable from parts of the internet because the traffic is going to be black holed. It's not going to be passing or being reachable from a certain part of the internet. Missing route objects might cause your BGP announcements to be rejected. So they do have a very important critical function. One tip that we can give you regarding route and route 6 objects, besides keeping them protected, is to update them when you're announcing new prefixes or changing the originating AS. So it's very easy to create a route or route 6 object, have your BGP sessions for a time, and then maybe you change the AS, which is going to be originating the prefix, and you just create a new object, but you don't delete the old object. And the idea is to keep an accurate registry is that you delete those objects if that's not what's going to be happening in BGP anymore. One other aspect that's not mentioned here on the slides, but that can happen if your route or route 6 objects aren't there, is that somebody else might take the opportunity to start announcing your address space. So because the object is not there and other networks are setting up their filters based on the presence of that object, anybody else could start announcing your address space from any other AS number, and there's nothing that will stop them. There's no route object or route 6 object that people can use to create their filters. AS set objects. So AS set objects represent a set of ASNs for an organization and customers. They're used a lot in peering automation. And these objects influence route acceptance policies. And we've seen several cases out there where the creation of an AS set affected the traffic or at least the BGP operations of another network. There have been some changes in the database, which I will talk about a little bit later, which help to keep these objects protected. AS set objects enable hierarchical filtering and they streamline the BGP sessions setup. One of the problems that could lead to your network one of the things that could lead to your network being unreachable is if these objects are deleted, modified, or tampered with in any ways. You could also be exposed to some security vulnerabilities, as AS sets are often used in route filtering and validation. And if somebody is able to access this object or at least modify it in any way, it could expose your network to various security risks, including traffic interception or denial of service. Peering problems is another thing that could happen if somebody were able to get access to your AS set object. Many organizations use AS sets as peering relationships, and they could probably affect peering arrangements and potentially break existing connections if they're able to, for example, modify the AS set by adding their AS number or removing an AS number. Yeah, other problems that might happen are, for example, automated tool failures. A lot of these automations for BGP or routing rely on the AS sets to be there. One tip that we can give you is to regularly review and update your AS set objects to reflect the current network structure. So keep your object up to date in order to take care of your interconnections. Domain objects. Now, domain objects have nothing to do with domains like www.ripe.net, but it has everything to do with reverse delegation, so reverse domains. Deleting domain objects from the RIPE database can have several consequences. That's because these objects are essential for reverse DNS to work. They impact email deliverability. Almost all mail providers out there do a check on reverse pointers to see if there's a reverse delegation to the domain for which mail is being delivered. They use an enum for VoIP and telephone services, and they aid in abuse handling and contact identification. So one of the problems when these objects are deleted is that your email will probably not be accepted anymore. You'll have problems, of course, with the reverse pointers. If you are relying on reverse pointers for any kind of network operations, that they won't be there anymore. Network troubleshooting difficulties. Reverse DNS is often used in network troubleshooting, and not having these domains there or having reverse delegation could lead to longer resolution times for network problems. And that means operational overhead, not just security problems. Some security systems use reverse DNS as part of their authentication process, and the absence of these domain objects could potentially cause authentication failures in certain scenarios. And of course, Reputation impact. A lack of proper reverse DNS is sometimes seen as a sign of poor network management. And this could negatively impact your organization's reputation among peers and clients. So it's actually really important that those objects, once you create them, stay there and are not deleted. Yeah, trace routing as well, right? So domain objects have operational impact as well. Again, a tip, and this always comes back to keeping the registry accurate, is keep them updated, especially after network architecture changes. It's really easy to create these domain objects and then forget that they're there because you just changed name servers or something. Keeping stale objects in the database also allows people to make use of them because they're there. So I'm not going to tell you how. I'm not here to teach you how to hack the system, but I can tell you that the system can be hacked. So make sure that you keep your registry accurate. So things to consider, general operational considerations are consistency. So ensure consistency across all your objects. For example, the origin AS and your root objects should match your AS set contents. Consider implementing automation for creating and updating these objects if you have, well, we've been shut down. And we're back up. It was you that entered. You turned off the screen. Anyways, consider implementing automation for creating and updating these objects. This can help to maintain accuracy as your network evolves. So if you are doing all this manually, it's easy to forget because you're relying on your memory to go and create these objects. But if you have a system that does it for you, it's much easier to keep track of this. Periodically review all your objects to ensure they reflect your current network state. This is particularly important after network changes or acquisitions. So make sure that your objects are reflecting the reality, what's happening out there. Implement a change management process that includes updating relevant RIPE database objects as part of any network changes. So put the registry into your workflows. Don't keep it as an afterthought. A lot of people just think, oh, it's the registry, you know, I just need it once and then I don't need it anymore, but that's not true. The registry remains an important part of your network operations, so make sure to put it into your workflow documented correctly. And before making changes to any of these objects, make sure to assess the potential impact on your peers and customers, because once you delete a route object, and you didn't realize that it was important, it takes some time for this all to get fixed. I don't know if anybody here can tell me how long it takes before a BGP filter is updated if I delete a route object. Depends on how frequently the BGP filters, right? So maybe an hour, a little bit more. So, you know, the impact can it happens slowly because it's not instant. But once that object is gone, all of a sudden your network starts being invisible on the internet. So make sure that you assess what the impact is when you do these changes. So let's talk about maintainers. This is the main security feature of the RIPE database. You know, the RIPE database is a public database. Anybody can access it to query it. Only the users that have maintainers, and these maintainers are linked or referenced in their address space or other objects, can they create, maintain, or change objects in the database. So the maintainer is the one obstacle between your objects and some malicious attacker wanting to wreak some chaos on your data. There are currently 3 authentication mechanisms. You have the MD5 hash password, the SSO authentication, and the PGP X509 certificate authentication. Now, if you haven't been listening to the RIPE NCC presentations in the past meetings and on the mailing list, the MD5 password hash password is going to be deprecated in 2025. So mid 2025, it's going to be gone. It's also the reason that it's going to be gone is because it's a really low security mechanism. If somebody gets access to the hash, they can just grab that and put it into some reverse brute force cracking and find the password. And then your maintainer is toast. The other mechanism, which is mostly used, is the SSO. It uses the RIPE_NCC access account. So you have to log into your RIPE_NCC access account in order to have access to this maintainer. It has medium security, meaning if somebody gets your username, your access account, and your password somehow, they can use this maintainer. Of course, with two-factor authentication turned on, it's much more difficult because they'll still have to figure that out. So SSO has the medium security. And of course, we have the PGP X509 certificates, which use either PGP keys or X509 certificates. And this is the highest security that you can get in the RIPE database. It's also the most complicated because you have to create a key cert object for in the database with your public key, and then use the private key to sign all your updates. The benefits of using MD5 hash is that you can use the RIPE database RESTful API. So you can use the API to do some automation. With the MD5 hash password being deprecated, there is a new solution coming up, which I will not be talking about here, but there will be a very nice presentation in the RIPE database working group session done by Ed, the software engineer in charge of the RIPE database. So MD5 hash password is going to be gone. SSO authentication stays, and so is PGP X509. You can use the X509 certificates to access the REST database if you want to create objects. It is a little bit more cumbersome, and I will show that in a couple of slides, but it's also possible. Like we said, MD5 is the oldest authentication method. It will be deprecated. And if you are currently using MD5 passwords or hash passwords, I do recommend you to transition to some other mechanism as soon as you can, because when the deprecation comes, we will remove all the hashes from the maintainers and they will not be usable anymore. The SSO authentication uses the RIPE_NCC access account. It's more convenient than MD5. You don't have separate passwords for each maintainer. So with one access account, you can control multiple maintainers. It's really easy. All you have to do is add an auth line with SSO and then the email address of your access account. There's also a little tool in the database when you have an MD5 password. If you try to use it, it will ask you if you want to associate your access account with the maintainer, and then you can have both the SSO, the MD5, and then remove the MD5 hash from your maintainer. It has a good balance of security and convenience because you need to have the access account and the password for that access account. And like I said, if you have two-factor authentication, it's really, really difficult to get access to these maintainers. Unfortunately, it cannot be used for automation, only interactive updates on the website. And what we've seen with the statistics is that this is how the majority of the people use the database. They go to the website and use the web updates interface. So this is the one that's the most popular at the moment. If you create a new maintainer from scratch, you will have the option of associating your SSO account into that anyways, into that maintainer. So all new maintainers are actually already using SSO. The PGP X509 certificate authentication is considered the most secure because you have a PKI. It uses public key cryptography. Like I said, you can use PGP or X509, and it provides maximum security for your critical objects. So I would suggest if you are attached to your route and Route 6 objects and AS sets, probably use a maintainer with an X509 or PGP key to make sure that they are protected. There's no shared secret between the client and server that could be exposed. And so as long as the private key is kept safe, your maintainer is safe as well. So recommendations regarding maintainers: if you're using MD5, plan to transition before 2025. Consider moving to SSO for a balance of security and convenience. If you want maximum security on your objects, use PGP or X509. And of course, regularly review and update your authentication methods. Now, I'm going to teach you how to create a key cert object, which will allow you to use X509 or PGP keys on your maintainer to protect your objects. So I'm going to do this step by step, and then I'm going to do a demo to show you how it works, or actually that it does work. So the first thing that you need to do is generate a self-signed certificate. We're going to do it with X509. We use OpenSSL as the software. Most Linux, I think, and Mac have OpenSSL already pre-installed, but otherwise you can go to the OpenSSL website and download it. The first thing you want to do is ensure that the certificate is at least 2048 bits. So make sure that you have a really nice key there. What we'll do is with OpenSSL, we're going to create an X509 certificate. We're going to tell it that the expiration date is 365 days. So this means that the certificate will be valid for 1 year. We are going to want to renew this every year to make sure that if there is a leak or some kind of hijack in our systems, in our private key is compromised, that it's not a problem for us. So remember to renew your keys every year. We're going to be telling it to use the RSA algorithm and a key length of 4096 to create the new key. And we're going to use the SHA-384 hash function for signing the certificates. So this is going to provide a really strong level of security. 4096 bits and SHA-384. Then we are going to, of course, specify the subject field of the certificate. We're going to set the country, in our case, to the Netherlands and to ripe.net. So the common name usually represents the domain name or the entity that the certificate is for. Then with the key out parameter, we're going to specify the output file for the generated private key. So in this case, the private key is going to be stored in or saved in a file called client-key.pem. So that's where we're storing our private key. With the nodes option, we're telling OpenSSL not to encrypt the private key. Normally, private keys can be encrypted with a passphrase for additional security, but with the -nodes option, we're telling the key to be stored in plain text. And then with the -out option, we're going to tell it where to put the self-signed certificates. And in this case, we're saving it in a file called client-cert.pem. So with this line, you can create two files. One is the key, the other is the certificate. And then we're going to put these into an object. So first of all, we're going to want to convert the certificate to ASCII because we want to put this object into the database. So we use the OpenSSL command x509-in and then the name of the file. This is going to show the certificate in an ASCII form, which we can then copy into either a text editor or directly into sync updates on the web updates interface. We're going to paste the certificate there, and then we're going to start adding the attributes that we need to create the key cert object. So the first line has to be key-cert, and we're going to use the keyword auto-1, which is going to tell the database to create automatically the unique identifier for this key cert. And normally what it does is it checks which is the last key cert object that was created, and it adds a 1 to that. So if this is the first key cert object, it's probably going to be x509-1, and then if the next one that comes is going to be -2, then the next one is going to be -3, and so on. So that's how the auto-1 works. And then on each of these lines, after the key cert, we're going to add an attribute certif. So this is going to be probably a lot of copy paste, copy paste. If you're good with the keyboard, it's going to be done in no time. And if you're good at scripting, you might want to create a script to do this for you. Of course, these objects have to be protected, the key cert. So we're going to end with the MNT by and the source. The source is going to be ripe if we're working in the ripe database. The demo I'm going to do is in the test database. So my source is going to be test. Like I said, you can do this directly in a text editor, or you can do it directly in sync updates if you want. Now, then we're going to copy and paste this object into sync updates and then send the update to the ripe database. And if everything was well, there's no formatting errors or any kind of missed typos in there, you're going to get back an object, which is going to be a key cert. And you will want to take note of the primary key. And the primary key is basically that one, X5093574. And this is what we're going to then be using to authenticate with our maintainer. We're going to add this as an authentication method into our maintainer. So it says here that we should be doing it. And that means that I'm going to expose myself by trying to create one of these key cert objects live and in person. So I'm going to, of course, get my instructions here. I'm going to go to the terminal, and I'm going to drag the terminal here onto the screen. You all can see it there, right? So unfortunately, it goes to the bottom there. There we go. Try to make this window a little bit smaller. You know what? Let's just leave it like that. Okay, so we're going to go to OpenSSL. And there you can see the OpenSSL prompt. I'm going to start typing the command. So rec to request X509. And then we're going to tell it to make it for days 365. We want a new key with RSA 4096. Use the SHA-384 hash. Oops, I think it's without a dash there. 384. And then we're going to add the subject. And then all this cryptography stuff. How many of you are familiar with cryptography? Good. So you know what I'm doing, right? You might want to explain it to me afterwards. No. Am I? Yes, there's a quote there too much. Let's see. Can I go back? No, I can't go back. Damn it. How did this happen? So, SHA-384, subject down. Now I have a quote, correct? And then it goes Anel. Let's go to Anel. I'll just type it as I have here. You know, I'm a trainer. I'm not a network engineer. How's that? Key out. So let's call it Prague -key .pem -nodes -out, and we'll call it Prague -cert pem. So let's press enter. Boom, something is wrong. What could it be? Let's see. X509, day 365, new key, RSA 4096, SHA-384, sub, subject. Okay. Have you ever heard of copy paste? There we go. Boom, copy paste always works. And there we have the 4006 private key, and we have the private key written to client key.pem. So what was the next step? We wanted to show the certificate in ASCII form. So we're going to do that with the X509 command. And there we are. We have our certificate in ASCII form. So I need to copy this, including the begin certificate and the end certificate parts. Okay. There we go. Copy. And now I need to have, of course, my browser, because I'm going to do it directly into the sync updates interface. Let's see if I do this. There we go. So of course, you know that you need to be logged into your Access account in case you want to do any updates to the database. I'm already logged in. I didn't want to have you go through the whole 2FA process. Here on the left side, we have the sync updates, and you notice that I'm doing this in the test database. Because why? Oh, come on. Why am I doing this in the test database and not in the production database? Because this is a demo. I don't want to be polluting the RIPE database with my tests. Come on. Anyways, I will forgive you for that. Let's see. Our next step was to add the auto-1 at the top. So we need to add the little thingy at the front, which was key-search colon auto-1. And then we need to add the certif in front of each of these lines. No. Apple Intelligence. Autocomplete thinks it knows what I want to type. It doesn't. So, what? So, copy paste. This is going to take forever. Just because I'm nervous. How many of you do copy paste in your daily work? Let's see how many lines we still have. Ooh, we got a bunch of lines here. See, I probably should have done this in a text editor, which works better. Sync updates is not a text editor, and even though they say, yes, you can do it in sync updates, I really don't recommend you to do this type of work in sync updates, but rather use a nice text editor, which allows you to edit the text in a much more... Yes, that's when we used the command previously, the X509 command. That does the whole thing. So we've got our certificate. We need to add the MNT by, which is going to be some other maintainer. I know one. It's just SM30, yeah, 30-MNT. That one I know. And then, of course, the source is going to be test. So let's do a quick review of our object here. We've got a key cert, we've got our certif lines. Let's try it out and see if we can create our certificate. And it has an error. Let's see what happened. Our error message is the following objects are found to have errors. Really? Not authenticated by SM30 MNT. Yes, of course, it's not authenticated by SM30. I'm going to show you one of the problems with MD5, and that's if you have the password, all you have to do is add it to the object, and this should work now. Voila. I have now my object that says it was successfully created. Our key cert is the first one, X509-1. So let's look it up. I'm just going to go query it. Where is it here? Boop. Here we go. We have our beautiful X509 certificate. You see that all the other attributes were added automatically. Method X509. We have the owner. We have the fingerprint and the certificate, and we can show the entire object here. So now we're halfway there. We have the X509 certificate inside our database. We would probably want to add it to one of our maintainers, but we don't have a maintainer yet. So I'm going to show you also that part. So adding a new auth to a maintainer. The first thing that you're going to do, of course, is search for your maintainer. Then you're going to click on update. In this case, I search for my maintainer in the right database. Then I click, of course, I had to log in. Then I click on update the object, and we have the object shown in a template. We have our existing SSO authentication right there. You can imagine why I'm blocking it, so you don't know what my SSO is. I'm going to click on that little arrow at the right side, and this is going to add a new clean, empty auth line. There, I'm going to add just the identifier for my X509 certificate, key cert object, and then I click on save, and the database shows me what changed. And you can see now that there's an auth line with my X509 certificate. So it says here that I have to do it. So let's do another live demo, of course. So I'm going to actually create a maintainer, role maintainer pair so that I have here something. I'm going to call this maintainer Prague, right, 89. Can I call it like that? Yes? No, it has to end in -mnt. So all maintainers have to end in -mnt. You thought you knew it, you don't. And I'm call it demo role. Let's just call it demo role. Let's add this hotel street 123. Now notice that the database is not checking anything that I'm writing here. I can add whatever I want. Prague, Switzerland. And I'm going to add my email because why not? So I'm going to click on submit. Now I have a role and I have a maintainer. I'm going to get this maintainer and add my X509 authentication. So all I have to do is look for my maintainer, edit it. I can directly edit it because when I created the maintainer, it associated my SSO directly. I click here on add, and then all I have to do is X509-1. That was the identifier of my X509 certificate. Submit. That's it. I have now an X509 certificate in my maintainer, which I can use to create objects and modify objects and delete objects and protect them with the highest protection there is. Very easy peasy. So the idea of having an X509 is not because you're going to be using the website to do your updates. That's why you have SSO for interactive updates, but rather to be able to use the REST API. So the REST API is an API using the RESTful paradigm to allow you to query, update, and create objects in the RIPE database. There are several different API endpoints that you can use. There are some which allow you to do just direct queries. So that would be the rest.db.ripe.net. But if you want to create an object in the database or update an existing object, for example, then you would want to use the rest-cert.db.ripe.net. At the moment, the MD5 hash password still works, so you can still use the normal REST API to using MD5 passwords to create objects and all that. But like I've been repeating, that's going to be deprecated by mid 2025. It's going to be completely gone, so don't invest your time on that. Make sure that if you're going to be doing any kind of scripting with the REST API, that you use the key certs. X509 in this case. There is also going to be the API keys introduced, but again, that's going to be presented during the RIPE database working group session. So if you're curious about that, don't forget to attend the database working group. So this is a standard curl command to do something with the using the REST database, and I'm going to explain bit by bit. So the first part is where you send the request with a header specifying the data format. In this case, we're telling it the data that I'm going to be passing is JSON. Then we're going to be telling it where this data is stored. In this case, it's in a file.json file. And we're going to be using the put method. And put allows you to update an existing object in the RIPE database. Then we're going to be telling it which key we want to use. In this case, we're telling it our client-key file is going to be used for the authentication. We have to, of course, also pass on our client certificate for verification. So we have both the private and the public part. And then we're going to tell it which API endpoint we want to use, which database, the type of object, and of course, the unique identifier, in this case, the nick handle of the object. We're adding .json so that it knows that it should be retrieved in JSON format. If you don't use JSON or .json, it's going to be using the default XML format. Oh, this is the part that I love, which is, of course, doing a live demo. Yes, let's go back to our little thingy here. We're going to do this in using curl, of course. I need to get out of my SSL. Let's clear this up. And that's much nicer. So first of all, I need to get my object. I'm going to be using this role object that I created to do this. So first of all, I'm going to use curl. And then I'm going to HTTP. I should use actually HTTPS / rest dash search, test.db.ripe.net. Now, I'm not using the cert endpoint because at this moment I am only querying for the object. I need to get the object in its XML format in order to use it. But in the modification, when I change the object and update it, I am going to use the REST interface. So I'm going to be using the test database, and that's why I use test and not RIPE. I'm getting my role object, and then I probably should have written down what my role object's identifier was. But that's okay. Let's do a reverse query. No, I don't need to. It's right here, dr1-test. Perfect. So we want the dr1-test, and we're going to ask for it unfiltered. And I'm going to send it to my data.txt file. So I'm working in a temp folder, and everything I do is going to be stored in this temp folder. So I have my output. You can see that it did something. I'm going to list the files. I have my certificate and key, and I have my data.txt. Let's check this data.txt file. As you can see, it's an XML version of our role object. What I'm going to do is modify this using my Finder. Yeah. No, that's not what I want. I want actually text edit. And I'm going to go to my text file, which I stored somewhere. Yes. No. Do you know what the problem is? That I put it in whatchamacallit, a folder that's not in the documents or anything. So I'm going to go old school. V. And I know just barely enough V to get through this. So it was dr1-test. dr1- no, I called it data.txt, right? Data.txt. There we go. So I want to add another attribute. Let's add an address attribute, because why address attributes are easy. So I'm going to just add it manually. I would copy it, but I really don't know how to copy in V. Now I'm adding an address attribute because addresses can be appearing multiple times in the object. So we sent it to Switzerland. This is not a real address. 321 slash. So I just want to add one attribute. I'm just putting any kind of string of text. It doesn't really matter. And I'm going to write and quit. Let's do again. And we can see our little addresses there. So if we would go to the test database and look up for this object, we can see that it does not have that line yet. So I'm going to now go back to the line and do the whole curl thing that we said that we're going to do. I do need my cheat sheet here. And I'm going to copy and paste. I've learned my mistake. Boom. And we're going to call it dr1-test. Now, I'm not adding JSON or XML or anything because the default format for the API is XML. I am telling it that the data is going to be in XML. I'm taking my data from the data.txt file. I'm telling it my key is the client key and the certificate is the client cert. And if everything goes well, we get a nice XML output telling us that the object was modified. So we get a success message. How can we verify that? Well, let's just go to our browser here and look for our object once again. There we go. We added an address line. All this work just for one line, right? Bro, thank you. So that is how you use key cert objects with the RIPE database API. As you can see, if I can do it, you can do it. It's very easy, and it gives you the highest security levels. Now, updates. when there is an update in the RIPE database, you only get this message on the web browser if you're using the web interface. But otherwise, how do you know if one of your colleagues managed to update an object? What about if somebody has gotten access to your maintainer and they update your object? How do you know if your objects are being changed? And that's why the RIPE database has the notifications functionality. So this is essential for maintaining an accurate and secure records, keeping track of changes. You can have different attributes for different notification needs. So you can have an attribute that checks for any modification on an object, or you can have an attribute that checks for failed modifications on an object. This helps to monitor changes to your objects. What notifications can you get? Well, in the maintainers, there's two attributes, the update to and the main notify attributes. The update to is going to send a notification when there's a failed update. So somebody's trying to modify one of your objects, delete it or change it, and they're not succeeding, probably because of authentication errors or any kind of error. It could be a typo. And so you're getting saying somebody's trying to change this object from this IP address. The main notify is sends it notifications when there are successful updates. So when a change has been done. And this is also very important because then you know who made a change to your objects. It could be route, route 6, ASet, or domain objects. These attributes are only used in a maintainer, and they are triggered when an object protected by this maintainer undergoes a change operation. So tries to do a change on an object. Yeah. And of course, a notification will be sent to the email address. What do the notification messages contain? Well, for starters, the type of update, if it's a creation, a modification, or a deletion, so what kind of change happened, the object type and the primary key. This is very important to know which is the primary key. The change is made to the object, so you're going to see a diff output, seeing what was the object like and what is it now. If it's a new object, of course, you'll only see the new object. The timestamp of the update, this is also very important, and the IP address and SSO account. Very, very important. So you can know from which IP address the update was done, or at least the reported IP address, and which SSO account was used to authenticate the change. As you know, you have to be logged into SSO, to your Access account, in order to do any changes to the database. You can see here a little example of my maintainer, which I modified just a couple of weeks ago. If you want to monitor any type of object, you can add a notify attribute. So any object can have a notify attribute added to it with an email address. And when there's a change to this object, an update, an email will be sent to the email address in this attribute. So it's regardless of who made the changes. If, for example, you want to make sure that your route 6, ASet, and domain objects are only changed by authorized people, or know when they're changed, add a notify attribute to these objects. And it's useful for monitoring all kinds of activities related to your objects. You can add multiple notify lines, so in case you want to send messages or emails, notifications to multiple recipients. Suppose you have several teams that are reliant on certain type of objects. Okay, energy cuts again. We're back. So you can add multiple notify lines to send a notification message to different groups, people, interested parties. There are special notification attributes which are only used on certain type of objects. For example, the ref notify sends a notification when the organization object is referenced. So you might have an organization object for your local internet registry. If you operate a local internet registry, you might also have an organization object for a customer, or it might be your own. Maybe you're a customer using address space from a local internet registry. And these objects, if there is no ref NFI, ref notify attribute, can be referenced in other objects with no problem. So you can just simply add an organization object and reference it in any other object, and there's nothing that anybody can do about it. But you might want to keep track of these references. So you can add a ref NFI attribute, like we see here to the left, and add an email address to which a notification will be sent when this object is referenced in another object. If you have an IRT object, an incident response team object, and a lot of large networks and organizations have them, you might want to have a notification when the IRT is referenced or dereferenced. That's also probably interesting to know. We might have an IP block and it is referencing an IRT, and then maybe somebody removes it or deletes the IP block, then this reference will be changed. And what you would do is in the inetnum object, you would add an MNT IRT pointing to the IRT object. This was reference the IRT object. And if you want to get a notification in the IRT object, you would add an IRT-NFI, notify, pointed to an email address where a notification will be sent every time this IRT object is referenced and dereferenced. So that way you keep track of these changes. Now, you can put notify messages all over the place, but you have to make sure that the mailbox works, because if the email address is unreachable, so the RIPE database gets a bounce message, then this address is added to a list, and it means that the notifications won't be sent anymore. As long as this mailbox is unreachable or cannot be reached once, it's added to a block list, let's say. So the RIPE database will not send any more notifications. If this happens to you, then the procedure would be to get your address removed from this list, to contact the support team at the RIPE NCC. You can email ripe-dbm@ripe.net. This is your contact point for the RIPE database support, first line, or through the contact form and explain which email address was not working at the time, maybe mailbox full or some other kind of problem. But as long as you don't request to get it removed, then the notifications will not be sent. Of course, we have to give you some tips on best practices. First of all, use appropriate notification attributes for your needs. So put notify attributes on the critical objects. Make sure that you're monitoring them. Regularly check and update your contact information. We don't access the registry every single day, all the time, maybe sometimes once or twice a year. If you're a normal network operator, large networks might have more need to access the RIPE database, and so they probably have more chances to keep their data updated. But for the regular user, it's not a service that you access very frequently. Monitor notifications to stay informed about changes to your objects. Sometimes the registry is operated by only one person. If you have several people in your team that are doing changes or might be doing changes, you want to make sure that you keep track of these changes and who did them. It's important to keep the accountability in order. And of course, use different attributes for different levels of notification granularity. You've seen that there are several different attributes you can use. So make a use of a mix of them. Put notify attributes on the critical objects and make sure that you have the attributes in your maintainer also set up. So it says here that I have to do it. Let's see. I will, of course, put a notify attribute on my role object just to show you how easy it is. I have here again my role object. I'm still logged in, so I can click on update object. All I have to do is find a nice place. I will put it right under the email. Click here on the little plus sign to add an attribute. I'm going to choose here the notify, and I'm going to add it. And I'm going to put here an email address. So let's put my work email address. And we're going to submit. And I now have a notify attribute. So every time I do an update to this object, I'll get a notification message. Now, demo says here that I should try modifying my object and doing a change. So why not? Only thing I'll have to do is first check if my emails are viewable. I don't want you guys to see my email where I get fired. I'm going to add another attribute. Let's see, what should we add? Let's add a fax number because why not? Faxes are cool. And I'll put the 31 for the Netherlands, 545, then 1234. Something like that. Will this fax number work? We don't know. Well, the RIPE database doesn't check if the fax number is real or not real. It just checks if it's in a format. So that's as far as it will go. Now, let me get my emails. And I'm going to do that in a separate window, if you don't mind. But I have to get it out of here. It'll just take a second. In the meantime, I have to log in through all the hoops and things that they tell me I have to do in the office. They were sitting here at the back, the people from InfoSec. They're gone now, so I can do whatever I want. No, that's not true. Mail. And here we go, RIPE database admin. I can show this now. See, I got here my notification message. Told me from host I have an IPv6 address because what? We're on IPv6 mostly at the RIPE meeting. Tells me the timestamp, date. Says here, this object used to be like this, and now it looks like this. And it says the SSO that changed it was me. So I can tell, okay, I was the one who changed it, or at least somebody who had access to my SSO account. Let's get rid of my email, not interesting. Go back to the slides. Controlling references to your objects. So I said, if I have, for example, an organization object and there's no attribute telling me that my object was referenced somewhere else, I will never know that somebody referenced my organization object. But that happens as well with person objects and role objects, and even maintainers. So somebody could reference my maintainer in somebody else's object, and there won't be any kind of checks. So in order to control the references, you have what's called the MNT ref attribute. This controls which maintainers can reference your objects and other objects. And you can apply this to organizations, persons, roles, maintainers, and IRT objects. So this enhances your security and control over your RIPE database objects, because if you don't have the access to the authentication mechanism of that specific maintainer, that's protecting the object, or at least the references of the object, it will not be able to reference it. So the main reference allows you to control which maintainers can create references. It's used on organization, person, role, maintainer, and IRT objects. And when an object tries to reference your object in another object, the RIPE database will check if the maintainer that is trying to reference is listed as a main ref. If the maintainer is listed, then the reference is allowed. If it's not, then the update is rejected. And you can list multiple maintainers in the main ref attributes, so you can add multiple main ref lines. And this means that you can delegate the power to reference your object to multiple maintainers in your organization, or at least to partners. If no main ref attribute is specified, any maintainer can reference your object. But I said that at the beginning. So how does it work? In this case, we have object A, which has a main ref pointing to net1-MNT. and it's protected by net2 MNT. Now, object B wants to reference object A in one of its attributes. It can be a admin C, tech C, so person or role object. It can be also an MNT by, a maintainer. It can be an org attribute referencing an organization object. So there's all kinds of possibilities. In this case, we add an attribute which is referencing the object A, and because this object B has an MNT by net1-MNT, then it is authorized. If I would have any other MNT by in my object B, then that reference would be rejected. To use MNT ref effectively, so add it to your objects to restrict who can reference them. For example, I added it to my person object. So my person object can't be referenced just anywhere. Include your collaborators, maintainers, if you have joint projects. So if there's, for example, an organization object for a customer, and we want to reference it in different INET-num or INET-6num objects, or even route objects, or any kind of other object where an organization can be referenced, we might want to share this responsibility by adding multiple ment-ref attributes pointing to our different maintainers. Regularly review and update this for security. If you are having changes in your maintainers, for example, make sure that you keep it up to date and align with your overall RIPE database management strategy. So what I'm hinting at here is try to have some kind of database maintenance strategy. Not just once a year or when the RIPE NCC does an ARC, but make sure that it's part of your workflow. So how does this work? For example, in organization objects, I have here an organization object. It says here type LIR, but it could be also type other. This object has been, of course, shortened. Let's say I've removed quite a lot of attributes so that it's readable. So this is not a real organization object. In any case, I have two main ref lines here. One is pointing to example-MNT, and the other one is pointing to partner-MNT. This means that both example-MNT and partner-MNT can create references to this organization object in other objects where they are working. Best practices are to use main ref on your important objects, so your organization, your person, your role, your maintainer, and your RRT objects. Be selective of which maintainers you include. So make sure that only the maintainers that should have referencing powers are there. Keep your mint-ref list up to date as partnerships change. So you might want to either keep external documentation or make sure that you know which objects you put a main ref. Consider the implications before leaving the main ref unspecified. So if you don't add a main ref, you know that your object will be can be referenced in any other object without asking for your permission. And use along with the other security measures in the RIPE database to keep your data nice, tight, and safe. So protecting references in set objects. So AS sets or other set objects are used a lot in the IRR, the Internet Routing Registry. And we have some ways of, the RIPE database has some ways of protecting your objects from being referenced in other objects, and of course, to allow certain types of references, for example, in AS sets or root sets. So the two attributes that are going to be helping us with this are member of and members by ref attributes. So these are used for set objects where we have members. Like in this case, we have an AS set, which has a whole bunch of different members, which are AS numbers. The member of will be used in objects wanting to join a set. So we would add it to an odd-num object, for example, if we want that odd-num number to be part of an AS set. Or a route, if we have a route set object. The members by ref is used in set objects to control the membership, because I don't just want any AS number being added to my AS set. I want to make sure that the AS numbers added to my AS set are the ones that I want to appear there. So how does this work? Well, we have on one side the Otnum object, in this case AS65000, and we add an attribute member of AS example. Now, with this attribute, the AS number would probably be added to the AS set. So it's requesting it to be part of this AS set. The set object is going to check its members by ref list. So it's going to check if the members by ref is pointing to a maintainer that is authorized to be added to the AS set. And if the maintainer of the requesting object is listed as a members by ref, then the membership is allowed. And if it's not there, then the membership is rejected. So it's very easy. You have a requester, that's the members of, and you have a sort of bouncer at the door, and that is the members by ref. If the maintainer in members by ref doesn't match the maintainer in the member of object, then it won't work. Member of can be used in Otnum objects for AS numbers, route 6, and INET RTR objects. So INET RTR is internet router, and there are some old IRR objects. I don't know if anybody here still uses them. Is this the first time you hear about them? Good. It's always nice to learn something new, right? So the member of will indicate the desire to be part of a set, and it can reference multiple sets. So you can have multiple members of. Like in this example, we say that this AS number 65000 is member of AS3333 AS example, but also AS 65050 AS customer. So we can add multiple member of and point them to different AS sets. In this other case, we have a route 6 object, and it's member of a route 6 set. Yeah. The members by ref attribute is used in AS sets, route sets, and router sets objects. This will list the maintainers that are allowed to add the members, like we just said, so it has to be reciprocal, and it acts as a protection mechanism. You don't just want your AS number to be added to any AS set, so you want to have this type of protection to control which AS number is being listed as a member in our set. So benefits of using these attributes is that you have enhanced control over the set membership. It's not, you can also do some kind of automatic membership thing if you add a nice maintainer that anybody else can add to their objects. It prevents unauthorized additions. It has a way of distributed management of the set membership. So you say, okay, I'm going to add this maintainer or your maintainer to my AS set object as a members by ref. And then all you have to do is add a member of to your object, and then automatically it will be part of my AS set. It gives you some improved security in your network resources. And the best practices that we can recommend are to use members by ref in all of your set objects. Make sure that you don't allow anybody to add to your AS set without your permission. Only list trusted maintainers in the members by ref. Use the members of when adding objects to a set. So if you put in, for example, a customer's maintainer as a members by ref, and then you just have to tell them, okay, add to your Otnum object a members of attribute pointing to your maintainer, to our AS set, and then it should all work. Regularly review and update your set memberships and keep documentation of your set structure and policies. If you just do everything in the right database and you don't remember what you did or why you did it, it's very difficult to do reverse engineering. So keep some kind of documentation on the reasons why you did anything. AS sets and the autonom object. So we talked about AS sets already. AS sets are a collection of autonomous system numbers, and the autonom object represents the individual autonomous system. So the AS number and who's holding it. The autonom object also holds a lot of routing policy information. Naming requirements and authorization process have taken place not too long ago. The AS set has a special naming requirement. You can't just create an AS set and call it whatever you want. It must start with a lowercase AS dash, so AS dash, and then whatever you want to call it. It can contain letters, digits, underscores, hyphens as well. And the last character must be a letter or digit. It cannot be a symbol. Hierarchical names are mandatory, and by hierarchical names, I will show you in the next slide, it means that we have to get authorization from an object higher in the hierarchy. The total length of the name should not exceed 80 characters. Now, you can write very long names with 80 characters, so don't worry, I think that's quite enough. When we talk about hierarchical AS set names, it means that it has to start with an AS number. It's going to take its authorization to be created first from an AS number, and it has to be followed by a colon. And then it has to end with an AS set names. At least one part must be an actual set name, so starting with AS dash. And then all the components have to be separated by colons. All set name components must be AS set names. And you can have nested AS sets. So we have here, for example, AS3333 AS customers. That's a first level AS set. We have here a second one, AS33333 AS transit, colon AS copper. We have another one, AS1234, AS5678, and AS peer. So we're having some kind of hierarchical authorization mechanism here in place. So the authorization from the autonom object, we said that the AS set name has to be authorized from the autonom. The AS set name must begin with AS hash. I'm repeating a lot of stuff here. The convention links to AS set with this authorizing AS send, and only the AS holder can create and manage this AS set. So if I want to create an AS set, I have to get authorization from my AS number, and only the people authorized with that AS number will be able to create and or modify this AS set. So that means that if I wanted to create an AS set which holds, it's just called, for example, AS-Amazon, which is something that happened, I think, a couple of years ago. Somebody was fooling around with the Amazon roots by creating an AS set in the database and pointing to all kinds of different AS numbers which had nothing to do with Amazon. And so they were doing some kind of let's call it denial of service, just to be nice. And this is because anybody could create any AS set called whatever they want. And if somebody was referring an AS set with this name, then it would cause some problems. So now only the holder of the AS number is authorized to create an AS set with that AS number attached. Best practices are to use clear, descriptive hierarchical names for AS sets, maintain a logical structure in your AS set hierarchy, regularly review and update, of course, your AS set memberships if a customer leaves or if some kind of peering relationship changes, you want to go and change your AS set, make sure that only the AS numbers that are supposed to be there are appearing there. Ensure proper authorization before adding ASNs to AS sets. We've already talked about the members of and the members by ref, so use that. And document your AS set structure and policies like we have here, for example, a little fictitious example. Different AS sets for different peering relationships. So let's talk about what's new in the database. If you haven't been following the changes, then I will tell you about two new INetNum statuses. The first one is the aggregated by LAR. So this was already in IPv6, and to have feature parity, it's now also in IPv4. This allows you to group multiple assignments under a single item object. So if you have multiple assignments of the same size or different size in IPv4, it doesn't really matter. You can register this in one single inetnum object. And if you want to, if all the assignments are of the same size, you can add an assignment size attribute, but otherwise it's going to be understood that this object is representing a bunch of assignments all gathered together into one single prefix. The other status is the allocated assigned PA, and this allows holders of very small PA allocations. For example, everybody who gets an IP4 allocation from the RIPE-NCC in the waiting list gets a /24, which is quite small. So it doesn't really make sense to register all small little assignments. You probably just want to register one /24, and that means that the whole /24 is in use. And this reduces the amount of objects that these LARs need to maintain. It's a sort of make your life easy thing. Let's look at these statuses one by one. So as you can see here, we have an inetnum. It has the status aggregated by LAR. And what this is telling me is that this range from 192.02.0 all the way to .3.255, this is an aggregation of assignments. There's a whole bunch of little assignments here. I still have my administrative contact, my technical contact, and in this case, I even have an organization linked to it. This reduces the administrative workload for LARs and, of course, simplifies the registration of multiple small assignments. It does help with GDPR compliance because you don't need to register all these individual records. So it's easier for LARs to manage and update contact information. The allocated assigned PA status, it's a whole, it indicates that this whole block is actually just an allocation with registered assignments. The change that an LAR has to do is not create a new object, but modify the existing allocation object. In this case, an LAR gets a /24, like we can see here, with the status allocated PA. All they have to do is, because the shared responsibility or maintenance of this item object, they can edit this object and change the status from allocated PA to allocated assigned PA. And all this is doing is telling the world this address space has been assigned, it is in use, it's not just an allocation. It can be used for any size inetnum block. So if somebody had a /16 IPv4 allocation, they could also go and change the status, but it would just make one large /16 saying this is all assigned, and you wouldn't have the granularity. It's more intended for the smaller allocation holders, that didn't get more address space. So we've come to the part that you've all been expecting for, almost the end. Are there any other demos that you would like to see? Yes, of course. Hi. Can we get a mic up here? Almost there. I'll tell a joke in the meanwhile. Why did the IP walk into the to the bar?
Does it work? Yeah.
Yeah.
Okay, I'm good. With new people dealing with RIPE database, I figured out they are struggling with the differences between objects that refer to route stuff and things that matter for address documentation. So whenever you talk about assignment and allocation, this is pure documentation, who uses what and what is being free.
Yeah.
And has nothing to do with routability.
Exactly.
This is why it's difficult to see that the objects almost look the same. Where it matters for routing with route entries and AS and everything, and where's the difference when you talk about address block sizes and something that is just for documentation that is in use.
Yeah.
And it's really easy to be confused with people that are new to the system. And I don't know if there's some way to distinguish more the route information and the network, let's say relevance, compared to the documentation, what's in use.
Yes. Well, basically, the way that you would see that is in the object type that you're looking at. And you can only see that if you know what you're looking at, right? So a person who doesn't know much about the RIPE database will go and look for an IP address. They'll get an inetnum object, maybe a route object. But the first thing that they'll get is an inetnum object. And they'll think, oh, this is the network, right? And there's nothing there telling you this is just a documentation object. It's just telling you that this address space has been handed over to somebody and is being used by somebody. But that's maybe something to propose to the database working group to indicate how these objects can be more easier to read, right? Unfortunately, the RIPE database is something that's difficult for newcomers because it looks like the matrix a little bit. You just see all these attributes and then stuff, and you have no idea what you're looking at. And that's why we do, of course, the training courses, and we have all the training material, and we try to share all the information so that at least whoever is really interested and knows what they're looking for in the RIPE database can understand and find something.
Uh, Hello, my name is Henry Burgley from Princeton University, and I had a question regarding AS set security. So you talked about a bunch of ways to make sure if I own an AS set that someone else is not putting AS numbers into my set.
Exactly.
But if I own an ASN, is there any security mechanism to make sure that no one references my ASN in an AS set that I don't want them to?
Yes. So we talked about the ref attribute, right? So you would probably add a ref attribute and just say only this maintainer is allowed to make references to this Autonome object,
Thank you.
right? And yeah, that's one way that you would probably protect your AS number from being referenced somewhere else.
Thanks.
You're welcome. Any other curiosities, questions, comments, demos? Has this been a little bit useful, enlightening at least? Okay. Then I'm going to wrap it up here. If you have any further questions, you can reach me at my direct email. And otherwise, write to the academy@ripe.net. I have here a couple of useful links for you in case you want to read further. We have the RIPE database documentation online, the RIPE database sync updates tool, and of course, OpenSSL in order to create your key cert object. Now, the slides are all going to be on the RIPE89 website. So in case you need a memory refresher, you can download them from there. And we have the step-by-step instructions on how to create a key cert object. I hope you all have as much fun as I did creating it. And I will see you around in the RIPE meeting. Thank you very much. And goodbye. I have to prepare for a Kahoot. Dum, 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 dum. Hi.